Now we've had an introduction to atomic structure, let's look now at nuclear radiation, so that's alpha, beta and gamma. But what causes something to be radioactive in the first place? Because there are some atomic nuclei that are unstable, and it's actually a lot to do because of the number of neutrons. Neutrons make things unstable. So then in order to lose energy and become more stable, the nucleus will give out radiation, but the key thing is, remember that it always comes within the nucleus. We would say that this process is random. We know that the atom will decay, but we can't tell you exactly which one will decay next. So when radioactive nuclei do decay, they give off alpha, beta and gamma, and it might happen really quickly or it might happen really slowly. But there's a name given to this, and that's the activity, and that tells us the rate at which the source decays. So here we have a radioactive nucleus, and it's decaying by giving off some radiation. Activity is measured in becquerels, or capital B, small q. It's slightly different to count rate. Activity is how many decays per second that are being released in all directions. But when you're trying to record using a detector or a Geiger-Müller tube, we can only measure the count rate because it's only going off in one direction. So the count rate will always be lower than the activity, just because you can't capture all of the radiation that's being released at any one time. So what is an alpha particle? Well, an alpha particle consists of 2 protons and 2 neutrons. Just like when you look at helium on the periodic table, it's the same, apart from it doesn't have the electrons whizzing around the outside. It's just the same as the middle part, the helium nucleus. A beta particle is also released from the nucleus, and it's a high-speed electron. In fact, something strange happens. One of the neutrons from within the nucleus turns into a proton, and at the same time ejects a fast-moving electron, and that is what we measure. And finally, gamma rays, they're high-energy electromagnetic rays, so they're not particles at all, and they have no change on the nucleus when they get released. It's just some energy being released in the form of a gamma ray.